let's go ahead and begin. So I noticed the little word "lec" on the bottom. What I will attempt to remember to do is video record each lecture, because that thing is a video record. And I'll post them to a YouTube channel and links will appear on the webpage. You may or may not find it useful. Hopefully you don't find it too useful, because I will frequently forget to actually do that. So don't rely on them, but if you want that extra recap, often it will show up. So let's begin with this. So I talked a little bit last time about two different philosophies you might have for solving an inequality. One of the philosophies you might have, if you want to solve, I don't know, then you might just take the inequality, do algebra directly to it. In this case, I guess we could add 3 to both sides. Oh, add 3. And there would be the solution to the inequality. I guess that would be. On the other hand, you might say, well, instead of solving the inequality directly, in order to solve x minus 3 less than 7, instead you'll solve the equality. And you'll say, well, that point, x equals 10, is the place where the inequality can change. And so, what would you do from there? You would say, well, let's check something that's less than 10. And see what you get. You get 9 minus 3 equals 6, which is indeed less than 7. Which is good. That satisfies the inequality. Yeah.
Why can't we use 10 right away?
Why can't we use 10 right away?
So like x equals 10, x minus 3 is less than 7. Or 10 minus 3 is less than 7. So then
so let's go ahead and check it out. So if you plug in x equals 10, we'll get 10 minus 3. Is that less than 7?
No.
No. So that tells us something. It tells us that if we actually plot the answer, and there's x equals 10, x equals 10 is not in the solution. Since we went and checked x equals 9 and got that it was in the solution, x equals 9 is good. And since x equals 10 is the only place where it will change, we know that all of those are in the solution set. And theoretically, it might be possible that everything bigger than 10 is also in the solution set. So you need to rule that out by plugging in something bigger than 10. So plugging in x equals 10 is important. But somehow we knew in advance that it would not satisfy the inequality. So you need to check something on either side of it. Yeah. No, not a question. Okay. Plug in something bigger than 10. That's 8, I think, so that is also false. So there is the solution. We get the same thing, negative infinity onto 10. This may seem like the more straightforward approach, but let's see an example where using that approach just won't work. And let's try this one. Let's now go into the notes. Let's solve the inequality x squared is less than 9. And in order to illustrate the approach that won't walk, so if you like, this is in the notes from last time. Cool. So what would you need to do to undo that square on the x? What would you want to do to both sides of this equation? Yeah.
square root.
Take a square root. And there are like 2 problems here. So here, I'll just take the square root. You would get x is less than 3. But you lose information whenever you undo a square with a square root. Right? There should be like a plus or minus 3 or something. But then you get something else that's like really silly. You get like 2 inequalities, and which one are you supposed to actually care about? And one of them is like not actually relevant, because let's check some inputs and see if this satisfies. Let's check some numbers that are less than 3. What is the numbers less than 3 you can make up? 2. Does 2 satisfy the inequality? It does. Can you think of something even more less than 3?
-1.
-1. Does -1 still satisfy the inequality? Yeah. But let's go forward. How about like -8? Is -8 less than 3? -8 is less than 3. But is -8 squared less than 9? No. So something's wrong. Something in this answer, something has gone amiss. So you need, if you're going to follow a technique like this, you need to think hard about what undoing a square with a square root does to inequality. Instead, I'll propose the following. Let's transform it to equality, solve equality. That'll tell us the points where inequality can change. And I mean, presumably plenty of you already know what the answer to this will wind up being, for the sake of illustration. So let's solve the equality x squared is equal to 9. But we already found the solutions to that. What are the solutions to x squared equals 9? X equals 3 and x equals -3. On a number line, there's -3, there's +3. So, we'll play the game where we gesundheit, take points between and beyond and see what happens. And maybe we'll even just think about what happens at those actual points. When you plug in x equals -3, you get this inequality being true. No, because you get -3 squared is 9 is less than 9. So you get something that's false. So -3 should be excluded. Similarly, +3 should be excluded, which we encode with an open circle. And now we'll just play the between and beyond game. So maybe I'll do this. I'll pick a number that's less than -3. If you do that, then x squared is less than 9 becomes, oh, this is supposed to be like down here where I have space, becomes 100 is less than 9, which is false. So since that -10 is some number less than -3, that tells me all of these points to the left of -3 are not in the solution set. So that means the solution set could consist of the interval between -3 and 3, and could consist of the interval from 3 to infinity. And we can determine that by just picking some sample points. What's the number between -3 and 3?
2, 0.
Great. Pick that number up, plug it into the inequality. Do you get that the inequality is true or false?
True.
True. And whichever one you chose, maybe I'll go with x equals 0 because that's the easiest thing. X squared is less than 9 becomes 0 is less than 9, which is true. So that tells me that all of these numbers between -3 and +3 are in fact in the solution set. What do you get when you plug in a number that's bigger than 3?
4.
Sure. Could plug in 4, could plug in 50. Pick your favorite number bigger than 3. Do you get the inequality as true or false? False. So, everything to the right of -3 is not in the solution set. So we've completely determined what the solution to this is. It looks like it's all the numbers between -3 and +3. Hey, that's an interval from -3 to +3, including or excluding endpoints. Excluding. So the solution to this inequality is the interval from -3 to +3. How do people feel about that? That seem okay? And so, importantly, this technique of just trying to do algebra to both sides didn't give us something reasonable. If you manipulate the equality and then determine how the inequality changes at the points where equality is solved, you'll get something meaningful. So the last thing I want to do in this note packet is introduce one last concept, the concept of absolute value. And to convince you that, well, really, you already know most of the things I'm about to say. Tell me what some absolute values are. Let's see, maybe I should instead ask. If I say the word absolute value, how many people want me to describe it before I ask you to compute it? Okay, so what's the absolute value of a number? The absolute value of a number is what you get when you take that number and forget whether it's positive or negative. So the absolute value of 5 is 5. The absolute value of negative 5 is the number you get when you forget that negative 5 is negative. Alternately, it is the distance on the real line from that number to 0. So let's see that in practice.
Move it down a little.
Oh, yeah. Thank you for pointing that out. So if there's, am I good now?
Yeah. Yes.
Okay. So if there's 0 and there's 5, what's the distance between these two? 5. There's 0, there's negative 5. What's the distance between 0 and negative 5? 5. On the real number line, what's the distance from 0 to 17? And of course, like any function, you can plug in complicated stuff into them. Let's compute the absolute value of 3 minus 6, and let's evaluate that from the inside out. So that'll be the same thing as the absolute value of, what is 3 minus 6? And now we can ask a question about distance. What's the distance from negative 3 to 0? Similarly, what's the absolute value of 6 minus 3? And maybe one last one of interest. So there's 0. What's the distance from 0 to itself? Nice. So, people feel pretty good about absolute values? And there's a geometric definition. It's a sense of distance. If you draw 2 points on a line, the distance from that point to 0 is its absolute value. There's an analytic formula, and let's try to figure out that analytic formula. It'll be a piecewise formula, so the way to read this is I'll give you 3 different formulas, one of which will apply when x is bigger than 0, one of which will apply when x is equal to 0 on the nose, one of which will apply when x is less than 0. Let's start with x equals 0. So the only number which is equal to 0 is 0. And what's the absolute value of 0? 0. If I give you any positive number, how can you compute the distance from that number to 0? And let's just try to get a feel for this. What's the absolute value of 5?
5.
Absolute value of 6? If I give you any positive number x, then the absolute value of x is x. It's just that same number again. Let's think about negatives. What's the absolute value of negative 5? Absolute value of negative 6?
6.
Absolute value of negative 7?
7.
So it looks like I just want to get rid of that negative sign. What's an algebraic thing you can do that turns a negative number into a positive number? What's the negative of a negative? Positive. So one thing you can do if you want to turn a negative into a positive is you can multiply it by -1, or stick a negative in front. In general, the absolute value of a negative number is just negative that number. And in order to maybe check that and reinforce how to read a piecewise function, let's do some computations. Let's try to compute the absolute value of 5 by following these instructions. So I'm going to try to plug 5 into the absolute value. So I'll look at these cases. Which of the 3 cases applies when x is 5? The first one? Because 5 is positive. So then you read the formula that corresponds to it. When x is positive, I just return x. So I'll just return 5. By reading that formula. Let's try to compute the absolute value of -5. And I'm going to shift down now so that I can point. So let's see. I want to plug in -5. So first I'll determine which case I'm in. Does this case apply? -5 is not positive. Does this case apply? No, negative 5 is not 0. So in this case must apply. Negative 5 is negative. Great. So I need to apply this formula. So I need to multiply it by an extra negative 1. I'll get negative 5, which, hey, that's 5, which I knew it should be. So there's now an algebraic formula for the absolute value. People feel okay about this? Yeah. And let's think about evaluation a little bit more. So let's try to evaluate, I don't know, this one first. 5 minus the absolute value of 1 minus 7. And we'll evaluate it from the inside out. So I'll want to do 5 minus 1 minus 7 is negative 6. So 5 minus negative 6. Either by thinking in terms of distance or in terms of that algebraic formula, what's the absolute value of negative 6? 6. So I'll place that absolute value of negative 6 with 6. 5 minus 6 is negative 1. People feel okay? Let's go for something slightly more complicated. Let's try to compute the absolute value of pi minus 4, by which I really just mean let's express it in terms of something that doesn't have any absolute value bars. I'll still want an exact formula, not a decimal approximation. So let's try to do this. So pi minus 4. So pi is somewhere around 3, right? It's like 3.14 something. So let's look at the thing inside of the absolute value bars. Pi minus 4. I need to decide whether it's positive, 0, or negative. Is pi minus 4 positive? No, because pi is somewhere around 3. 3 minus 4 is negative. It's not 0, it's negative, I guess. So that means in order to evaluate the absolute value of pi minus 4, I need to multiply the whole thing by negative 1. So the absolute value of pi minus 4 is negative quantity pi minus 4. Because I need to multiply the whole thing by that negative. And maybe I'll simplify that a little bit. That's the same thing as 4 minus pi, after doing some arithmetic. People feel pretty happy? People okay with this? And let's do one more that'll be just slightly more abstract. Let's suppose I give you x, a number that's bigger than 7. That's all I'm going to tell you about x. Let's express x minus 7 without any absolute value bars using that information. So let's think about it. So I'm telling you that x is bigger than 7. I need to care about which of the 3 cases apply. If x is bigger than 7, then is x minus 7 bigger than 0?
Yes.
Yeah. So I'm given x is bigger than 7. We'll get x minus 7 is bigger than 0. So case 1 in the formula applies. And absolute value of x minus 7 is just x minus 7. Okay, pretty good. So all that was talking about how to measure the distance from a number to 0. But obviously, if I'm going to start talking about distances, I'll want to talk about the distance between two given numbers. So let's do that pictorially. By looking at this number line, what's the distance from negative 3 to 2? 5. Similarly, the distance from 2 to negative 3 is also 5. In general, if you want to compute the distance between any two numbers, the distance from x to y is just the absolute value of x minus y. And presumably that's not news to anyone, but it's worth saying the words. Everyone feel pretty okay? Any questions so far? All right. So, I mean, let's just, right, that's a bit of notation. The distance formula, the distance from x to y is given by d of x comma y, is absolute value of x minus y. So the distance between 2 and 4 is equal to 2 is the same as saying the absolute value of 2 minus 4 equals 2. People feel pretty okay? So I think I'll close with just one last computation, and I need to figure out how to make these notes less optimistic, because theoretically I was supposed to have made it to this point with 5 or 10 minutes left to leave you guys to work on that, but that didn't happen, did it? Guess I was off by 25 minutes. So, let's think about solving an inequality involving absolute values. Let's try to solve the inequality, the absolute value of x minus 5 is less than or equal to 4. And we'll do it two different ways. First, we'll do it in a purely algebraic way, and then we'll do it in a purely geometric way. So, the purely algebraic way, we have a framework. Step 1, we replace inequality with equality and solve. So let's solve absolute value of x minus 5 equals 4. And so there's already something weird here. That absolute value, I don't know a way to undo it. But I do know one thing. There are only two numbers that are exactly a distance 4 from 0. There's 0. What numbers are there that are exactly 4 units away from 0? Negative 4 and 4, that's it. There's 4, there's negative 4, that's a distance of 4, that's a distance of 4, and that's it. So I'll wind up saying this thing inside the absolute value bars, x minus 5, must be 4, or x minus 5 must be negative 4. So now I've taken one equation involving an absolute value and reduced it to two simpler equations. Those two equations look pretty simple to solve. Yeah, right? If I want to solve x minus 5 is equal to 4, I need to add 5 to both sides. Same thing there. Everyone feel pretty good? But I didn't want to solve equality, I wanted to solve an inequality. So let's play this between and beyond game. So there's a picture, there's x equals 1, there's x equals 9. And what am I going to do? I need to check some numbers between and beyond. Maybe we'll start by checking x equals 1 and x equals 9. When you plug in x equals 1, do you solve the inequality? Do you satisfy the inequality, rather? Yeah, because you get exactly 4 on the nose. So x equals 1 should be included. X equals 9 should be included for the same reason. Both of those give you an absolute value of x minus 5 equal to 4. And now let's check something beyond. I'll plug in x equals 0. I'll leave it to you guys on your own, because I'm going to be slow, to pick a number between and pick a number to the right. When you plug in x equals 0, what do you get? You get absolute value of x minus 5 equal to, well, that's the absolute value of negative 5 is just 5, is less than or equal to 4 is false. So all of these numbers to the left of negative 1 do not satisfy the inequality. And presumably at this point, you guys have picked a number between 1 and 9 to plug in. What did you get? I called something, but it was very quiet. I guess it's a yes or no. So you picked a number between 1 and 9. How many people got that the inequality is satisfied? Okay, good. Yeah, it is, right? I don't even care which number you picked. So all the numbers between 1 and 9 satisfy the inequality. What about the numbers bigger than 9? Do they satisfy the inequality? Nope. So the interval, the solution is all of the numbers between 1 and 9, including or excluding 1 and 9? Including both. Cool. Let's also do this geometrically. Absolute value of x minus 5 less than or equal to 4. Let's just translate that into words. I want all numbers for which the distance to 5 is at most 4. Does that make sense how those are the same? Right, the absolute value of x minus 5 is the same as the distance from x to 5. I want all the numbers for which that distance is less than or equal to 4. So let's just straight up draw a number line. There's 5. I want all the numbers that are a distance of at most 4 from 5. So how far to the right can you go before the distance becomes bigger than 4? Well, let's see. Let's just go to the right 4. 5, 6, 7, 8, 9, 10. So let's see. There's a distance of 1. This is a distance of 2. There's a distance of 3. There's a distance of 4. And that's as far as I can go, right? If I go any further, I will have gone past 4. So this is one of the endpoints, which I guess is x equals 9. And similarly, how far to the left from 5 can I go? Oh no! That cup walks surprisingly well. How far to the left from 5 can I go?
1.
Down to 1. By the same thing, 1 is 5 minus 4, so this distance is exactly 4. And it's always nice when you can attempt the same problem 2 different ways and get the same answer. It really should build confidence that it's correct. Any questions about this?
Can you move the paper over?
Yeah. Cool. So you may have noticed that I did post homework for today already, along with the caveat that depending on how far through this note packet I go, some of that might be shifted to being assigned on Monday. Presumably not too many people did today's homework already, because I think I only posted it a few minutes ago. No, longer. Doesn't matter. So we just did a bunch of geometry on the line. But a lot of times you want to do geometry on the plane. You can draw a picture of a blackboard. You can ask about the distance between points. How can you parameterize that so I can translate the geometry into some analysis and some algebra? And that's what we'll do next. I'll coordinatize the plane. I'll find a way of encoding all the points on a plane in terms of a pair of numbers. And presumably everyone knows a bunch of this already, so I'll go fast. I will develop the Cartesian coordinates. Named for Descartes, the same guy who is credited with the cogito ergo sum statement. I think therefore I am. So let's do this. So in order to build the Cartesian coordinate plane, we'll start by drawing a number line. So there's 0, there's 1, -1, 2, -2, and so on. From that number line, I will draw a perpendicular number line so that the zeros line up. So this point I'll now call 0, 0. Going up, I'll see positive numbers, 1, 2, 3, negative numbers, -1, -2, -3. And in order to navigate around this plane, if you want to get to some point, all you need to say is how far to the right should you go, how far up should you go. That'll tell you everything, how to get to any given point. So let's start with an example. To get to the point 5, 3, start at 0, 0, travel 5, as the first number is 5 to the right, so I'll maybe reindex my hash mark so that I can get 5 to the right. 1, 2, 3, 4, 5. I'll travel a distance of 5 horizontally.
Gotta move the geometry.
Yep, thank you. And then I will travel up by 3. One, 2, 3. So there is the point 5, 3. Everyone feel pretty okay? The convention is if you see negative numbers, then just travel in the opposite direction. If you want to get to negative 4 comma 2, I will travel 4 to the left. 1, 2, 3, 4. And 2 up. 1, 2. So there's the point negative 4 comma 2.
The one you supposed to. Just off that typo? Yeah. Up by one?
I don't know what you're talking about. It's not like you have the typeset thing in front of me, so this change that I make doesn't disguise anything. Yeah, typo. So maybe a thing to point out is it's an unfortunate convention in mathematics that the notation for an open interval is the same as the notation for a coordinate point. From context, you'll be able to tell when one is one and one is the other. So the further convention gives a labeling for the different quadrants that this gets broken up into. And they're just labeled counterclockwise, starting with the first quadrant being the right top one. And let's just read them off. So all of that should be just in terms of inequalities. So all these points in quadrant 1 are the points that you get to by going to the right and by going up. So that means that there are points that look like x comma y, a pair of numbers, where both x and y are positive. Quadrant 2, if I grab a point in quadrant 2, right, it's still some x comma y coordinate. To get to that point from 0, 0, do you have to travel left or right? Left, and then up or down? Up. So that means the first entry is negative, second entry is positive? So quadrant 2 is all points with x coordinate less than 0, y coordinate bigger than 0. Quadrant 3, they're both negative. Quadrant 4 has x coordinate positive, y coordinate negative. People feel pretty good? So, in the interest of covering maybe more than I would otherwise, let's go ahead and skip over to the next topic. Maybe before I do that, for how many people did that not feel familiar? Okay, good. So, just like you can compute the distance between points on the line, you can compute the distance between points on in the plane. The trick is you use the formula for the length of the hypotenuse of a right triangle coming from geometry. And let's do that. So here are some points, negative 1 comma 1 and 2 comma 3, together with a right triangle. So let's see, the distance between these points is exactly that red line. So if you want to know the distance between those 2 points, you just need the length of that line. But that's too hard to compute on its own. Instead, let's try to compute the length of the base and height of that triangle, because then the formula for the hypotenuse will just give it to us, the Pythagorean theorem. So looking at this triangle, how long is this base? So right, this point will have x coordinate 2 and y coordinate 1. So that base has length 3. What's the height of this triangle? 2. The Pythagorean formula gives you a way of computing the length of the hypotenuse of a right triangle. And maybe we'll recall that very quickly. If I give you a right triangle with length A, height b, then what's the length of the hypotenuse? What does the Pythagorean formula say? Yeah. Or if you're just interested in knowing what c is, I guess it says that the square root of a squared plus b squared is equal to c. So we can use the Pythagorean formula to compute the other length. We'll see that the distance is equal to the square root of 3 squared plus 2 squared, which appears to be the square root of 9 plus 4, or the square root of 13. If we wanted to compute that and get a decimal approximation, I'd have to take out a calculator at this point. On the other hand, I could do at least this much. So what's the perfect square that's immediately before 13? 9? So that tells me that the square root of 13 should be just a little bit bigger than the square root of 9. So this will be somewhere between 3 and 4. So it'll be 3 point something. And someone who's already taken out a calculator, I saw some people poking around. What is the square root of 13? I guess it doesn't matter terribly much.
3.6.
Cool.
5.
That's good enough for me. And so, that tells you what the hypotenuse is, but the hypotenuse was exactly the distance. So the distance between these 2 points is exactly the square root of 13, which is somewhere around 3.6. Maybe I'll make the following comment. So I'll often ask for one or two different things. I'll ask for decimal approximations sometimes, and I'll ask for exact answers sometimes. Square root of 13, I would say, is the exact answer. 3.6 is the decimal approximation. Because 3.6 isn't actually the same as the distance, because 3.605 would be closer to the distance than that is. But 3.605 is also not exactly the distance on the other. So on occasion, I will sometimes ask for an approximation. Sometimes, more often, I will ask for an exact answer. So in general, there was nothing special about the points I chose, right? You could have done this for any pair of points. If you did it for absolutely any pair of points, you would wind up with a formula for the distance between 2 points. If you want to compute the distance between 2 points, x1, y1, and x2, y2, what do you need to do? Well, you need to get the distance between the x coordinates squared plus the distance between the y coordinates squared. People feel okay? And that's I think what I'm about to do is I will have you guys right now take a quick aside, compute for me using that formula the distance from the point negative 3, 5 to the point 3, 2, with the goal that I will use this. Well, I won't spoil anything. here are pretty decent critical mass of people plugging away on the machines. So what is this distance on the nose exactly? 3 root 5. What is it approximately?
6.7.
How many people had as their exact answer the square root of 45? Yeah, so that is a correct answer. Maybe I'll say that 3 root 5 is slightly more simplified. So one thing you should do when you see a quantity under a square root, you should ask yourself, are there any perfect square factors under that square root? And do you see any perfect square factors of 45? 9, because 45 is 9 times 5, so you could pull that 9 out as a 3. People feel pretty okay about that? People want me to talk through any of the computation? Any interest in me talking through a computation? Okay. Regardless, I am going to talk through a computation because I'm going to talk through a computation and do it wrong, and you guys will tell me where it goes wrong. So here is a computation of that same thing, the distance from -3.5 to 3.2. So step 1, just use the formula. The square root of the difference between the x values squared plus the difference between the y values squared. Is there any error in that cost line? No, it looks okay, right? -3 minus 3 is -6. 5 minus 2 is 3. That seems fine, right? Square those, you'll get the square root of 46 plus 9. Good. Which is the same thing as the square root of 46 plus the square root of 9. Yeah, that's wrong, right? And that is a really easy mistake to make if you're not being careful, right? It's really appealing to want to just split everything over sums or products willy-nilly, but square roots don't have that nice behavior. And maybe I'll even be super vague. They're not nice, whatever nice means, over addition. And that's the thing to be careful about. Cool. Okay. So there are a few more. I certainly don't have enough time to finish everything that I want to today, but the stuff I'm not going to get to, I think will segue pretty well into the stuff tomorrow anyhow. So, the next thing I want to introduce is the concept of a midpoint. And the midpoint seems pretty straightforward, right? It should be like the point that's exactly halfway between two numbers. And in terms of just two numbers, what is the midpoint? Well, it's the same as the average. The midpoint between two numbers, a and b, is a plus b over 2. And maybe even just to check that, let's see if the midpoint between 4 and 10 is what it looks like it should be. So if you try to compute the midpoint between 4 and 10, you'll say, well, that should be 4 plus 10 divided by 2, which is 7, I think. But that should mean something geometrically. So let's draw a picture and see if the geometry seems to work out. So there's 4, 5, 6, 7, 8, 9, 10. And apparently the midpoint between 4 and 10 is 5, 6, 7. That actually appear to be halfway between. So I think I believe the formula. If you want the midpoint between 2 points on the plane, just take the midpoint of their x coordinates and the midpoint of between their y coordinates. The midpoint between x1, y1 and x2, y2, it should be a point in the plane. So there are going to be two numbers with commas separating them. The midpoint between their x coordinates, comma, the midpoint between their y coordinates. People feel pretty okay? Yeah. And let's just see if it looks reasonable. Let's compute the midpoint between -1, 3 and -3, 1. So the midpoint should be exactly -1 plus -3 over 2, comma, 3 plus 1 over 2. And what is that equal to? -2, 2. And let's see if this actually makes sense. So -1, comma 3 is -1, 1, 2, 3. -3, 1, 1, 2, 3, 1. That looks like a straight line between them. And there's the point -2, 2. That looks like it's about halfway between. And if it didn't look halfway between exactly, then, well, I would say that you probably shouldn't trust my ability to draw things to an appropriate scale anyway. Nice. So, 4 minutes left. Once you have the ability to do all this geometry in the plane in terms of analysis, well, the plane is exactly the place where you want to visualize solutions to certain equations. So we just went the way of talking about some geometry and translating into something analytic. Let's go the other way. Let's take something that's analytic or algebraic, some formulas, and try to translate them into things in the plane, because then we can do geometry on them. So let's talk about graphing solutions to equations. So the graph of an equation is just all x, y values which satisfy it. So if I give you an equation in 2 variables, like 2x minus y is equal to 6, the graph of that equation just means all points, x comma y points, with 2x minus y equals 6. So just all points which correspond to coordinates that satisfy the equation. And so you can at least answer easily now, yes, no questions, is this point on the graph or not on the graph? If you want to see if 2 comma 6 is on the graph of the equation, what do you need to do? You need to see if this equation is satisfied. So for 2 comma 6, you'll get 2x minus y becoming 2 times 2 minus 6, which is, I guess, -2, which is not equal to 6. This point is not on the graph. So do you think that you could now tell me whether those remaining 3 points are or are not on the graph? Yeah. Do it now. This will be like the last thing we do. Let's let me just answer some yes/no questions. We'll get out of here. So I think the consensus is that people say no. 6 comma 6, on the graph or not on the graph? On the graph? Yeah. 5 comma 4? Yeah, on the graph. On the graph? 3 comma 2? Not on the graph. Everyone feel pretty good?
Yeah.
Nice. Well then, I'm done, but I'm going to stay here anyway. So let's see. I sent out a mass email. Did everyone get that mass email about office hour change? Yeah. Did anyone not? Okay. The Wednesday office hours have been moved. Let me show you. So,
I saw like the list of like what it has to have. So is it based off of like that?
yeah, so is it correct, complete, and readable?
Okay, so it has to be like completely correct. So like the answer has to be correct for each problem.
Yeah, so in order to get a problem completely correct, you better have the right answer.
Okay.
And you better have a reasonable work problem.
Okay.
And it better be, readable.
Okay.
If you want to show me what you've done on like Monday, come by my house and I'll take a homework and
Okay.
just make
Yeah, I have it done. I can show you now.
Thanks, have a good weekend.
You do. I won't go and like check your answers because
Oh yeah.
that would take several minutes, I think.
It's like kind of like this. For ones where like it is find the value of the expression like if that equal I did like 4 numbers. 61 to 65, so like I didn't have to rewrite it. Does that mean like
Yeah.
you know what I mean?
Yep.
It's kinda like that.
Yeah, that looks readable.
Okay.
Yep. And you've included enough loss that I think that it should be followable.
Okay.
I can't speak to the correctness because I stared at it for 10 seconds.
Oh yeah.
I don't mind it.